Hey guys, and welcome back to my video series on solving other types of equations. In this video, which is number 4 of the series, we're going to look at solving equations that are in quadratic form. So let's jump right in. So solving other equations in quadratic form. Well, the first obvious question is, what is quadratic form? And we know this. It's ax squared plus bx plus c equals 0. But wait a minute. We did this already. That's just solving quadratic equations. I have a whole series on that. If you haven't checked it out, you should. But we've already done this. So if this is a new topic, we must be talking about something different. So what is that? Well, that's something like this. When we have x to the fourth minus 8x squared minus 9 equals 0. Looks very similar to our first equation up here, but the only thing that's really different is our exponents. So what do we do here? How do we solve these, and what do we do? Well, we use substitution, and we use substitution. For this example, we can let u equal x squared. Then u squared is just x squared squared, which is x to the fourth, and we can see that we have an x to the fourth, we have an x squared, and so now if we substitute those in to our equation, now we have something that looks just like our regular quadratic equations, and we can solve it normally. We factor, in this case we can just factor it out. We use the zero product property to set both equal to 0 and solve. And now we have solved for u. But that's not our goal. Our goal is to solve for x. So what do we do here? Well, our u is equal to x squared. So what we do then is simply change u back. We have x squared equals -1 and x squared equals 9. Then we use the square root property to solve for x. The square root of -1 is I. We have to do plus or minus, and we get plus or minus I and plus or minus 3, which gives us our solution set. So this is how we solve equations that are in the quadratic form, and sometimes they'll be more obvious than other times, but we'll go through quite a few examples so that we can see all those different forms and what they look like and how we solve them. So let's go ahead and start. So here's our first example. 4x to the fourth equals 3x squared minus 9. So the first thing we want to do is put everything to one side. So we'll have 4x to the fourth. We'll subtract 13x squared from each side and add 9 to each side. And we'll get 4x to the fourth minus 13x squared plus 9 equals 0. Now we're going to use our substitution, and we're going to have u equals x squared. Then our u squared is our x squared squared, and when we square it, we multiply the exponents. 2 times 2 is 4, so we have x to the fourth. So now we'll put that back into our original equation. So we have u squared is x to the fourth, so we have 4u squared minus 13 x squared is u plus 9 is equal to 0. And now we can use any of our regular quadratic formula tools to solve this. Now I went ahead and solved this by factoring, and I'll let you know that it took some trial and error to figure out exactly which ones would work, and I found that 4u minus 9 times u minus 1 would give us that equation. What I did was I took the multiples of 9, which is 1 times 9 and 3 times 3, and the multiples of 4, which is 1 times 4 and 2 times 2, and I kind of just plugged them in and played around with it until I got something that would give me -13 in the middle. And you could see that 4u times -1 is -4u, and 9 times u is -9, and -9u minus 4u will give us -13u, so that'll work out. Now we use the zero product property and set them both equal to 0. And we will get that u is equal to 9/4 and u is equal to 1. Now in this case our u was x squared, so we can just change this to x squared is 9/4 and x squared is 1. And using our square root property, we can take the square root of both sides, remembering we have to take the plus and minus, both positive and negative, and we get x equals plus or minus, well, the square root of 9 is 3 and the square root of 4 is 2, and x equals the square root of 1 is just 1. So we get our solution set of negative 3/2, negative 1, 1, and 3/2. And again, it's always good to check and make sure that all of these are in fact valid solutions to our original equation. It can get a bit tedious, and since it's just plug and chug, put it in and make sure that the answer that comes out is what you want it to be, I'll leave that up to the viewer, let you guys do that. But this is how we solve, and we just kind of want to get really good at the process here. So let's look at another one. In this one, it's different. We have 2x minus 7 root x minus 30 equals 0. And a lot of these equations in the book, they're nice enough to put this in the form that we already want it to be. We want it to look like ax squared plus bx plus c equals 0. So a lot of the times it's already in that order. Sometimes it's not, and you're going to have to check it out, but it's always good to look at this middle term first and see if we make u root x, what is u squared? Well, it's root x squared, which is just going to be x, and that is in fact our first term. So we know that that'll work out nicely. So we have 2u squared minus 7u minus 30 is equal to 0. And again, we have an equation in the quadratic form, and we can go ahead and solve it anyway. You could use the quadratic formula, you could use any of the tools that you learned in the past series to do that. So I'm going to go ahead and use factoring. What I get is 2u plus 5, and again, this happens by trial and error, u minus 6. Here we can see that 2u times negative 6 is negative 12, plus 5u, our inside terms, will give us negative 7, and 5 times negative 6 will give us negative 30. So we go ahead and use the zero product property, and we solve for u. So here u equals 6, and here u equals negative 5/2. Now this point, it's important to not just say, oh, x squared is u, because we have to remember, wait, what did we make u? In this case, we made u the square root of x, and so that's what we need to sub back in for u. So we have the square root of x equals 6, and the square root of x equals negative 5/2. So we solve this as we did in our radical section by squaring, and we see that we get x equals 36 and x equals 25/4. But wait, here we have a positive square root of something is equal to a negative number. That's not possible. If it had a negative square root, then it would be possible, and when we square it, that does work out. And if you watch the video on solving other equations with radicals, we kind of talked about this and talked about when we get this negative number, what happens when we square each side, and why it's so important that we check when we do square each side. So we can already see that this 25/4 is not going to work out. Well, let's go ahead and check it out. So we have 2, and we had 25/4 minus 7 times the square root of 25/4 minus 30 equals 0. Well, this is going to reduce that, and we'll get 25/2 minus 7 times square root of 25 is 5/2 minus 30, and that's going to give us 25/2 minus 35/2 minus 30. Well, 25/2 minus 35/2 is going to give us negative 10 halves, which will give us negative 5, and minus 30 is going to give us negative 35, which clearly does not equal 0, which is what we expected. But we could do the same thing with our other answer, which is 36. So if we do 2 times 36 minus 7 times the square root of 36 minus 30, then we see that 2 times 36 is 72, minus the square root of 36 is 6, and 6 times 7 is 42, minus 30. Well, negative 42 minus 30 is going to give us negative 72, and that will give us 0. So we can see here that by checking or by kind of just paying attention to our solution set, that this is not a valid solution to our given equation, and our solution set is just 36. So it's always good to check with these, and also just to kind of pay attention as you're going along to make sure that what you are solving, what you're getting, makes sense with what you have. So let's look at another one. Alright, here we have x to the negative 2 minus x to the negative 1 minus 6 equals 0. Again, they've been nice enough to put this in a form that we're used to, because if we let u equal x to the negative 1, well then u squared is x to the negative 1 squared. And when we do this, we multiply our exponents, and negative 1 times 2 is negative 2, so we get x to the negative 2, and that is in fact what we want. So this will give us u squared minus u minus 6 is equal to 0. And again, we have something in the quadratic form that is fairly easy to factor. So 6 is 2 times 3. We don't have an a coefficient, it's just 1, so we put our u's in. Now we want a negative here, so we need the negative number, to be bigger than the positive number. So we have u minus 3 and u plus 2. And in fact, negative 3u plus 2u will give us negative u. So using the zero product property to solve, we set each equal to 0, and we'll get u is equal to negative 2 and u is equal to 3. Now again, we have to really make sure we remember what our u is, and in this case it's x to the negative 1. So this will give us x to the negative 1 is equal to negative 2, and x to the negative 1 is equal to 3. Well, we can remember that x to the negative 1 is just 1 over x. So we have 1 over x is equal to negative 2, and 1 over x is equal to 3. If we multiply both sides by x, we have 1 equals negative 2x for the first equation, and 1 equals 3x for the second equation. Now dividing here by negative 2, we have negative 1/2 equals x. And this one, dividing both sides by 3, we get 1/3 equals x. So our solution set in this case is negative 1/2 and 1/3. And again, it's always a good idea to put those back into our original equation to check to ensure that both solutions are valid for our given equation. Alright, so let's hop right on to another one. Alright, here we have rational exponents. So we have 2/5 and 1/5. And so remembering that when we raise an exponent, we have like xa to the b equals x to the ab, we multiply them, we can see that 1/5 squared is going to be 2/5, because if we have x to the 1/5 and we square it, that equals x to the 2 times 1/5, which will give us x to the 2/5, which is what we want. So let's go ahead and let u equal x to the 1/5, which will give us a u squared of x to the 1/5 squared, which we know is x to the 2/5. And plugging that in, we have u squared plus u minus 6 is equal to 0. That's just like the problem that we just did, except in the previous problem we had two minuses. We had minus u. This time we have plus u, which means that we want our positive number to be bigger than our negative number. And we'll get u is equal to 2 and u is equal to negative 3. Now, our u is x to the 1/5. So substituting that back in, we get x to the 1/5 equals 2, and x to the 1/5 equals -3. Now we can go about solving this just like we did in the previous video when we solved equations with rational exponents. And remember, we would multiply by the reciprocal, raise it to the reciprocal. So the reciprocal of 1/5 is 5, so we can raise both to the 5. And here we have m over n. Our m is 1, so we don't have to worry about a plus or minus. So we'll get x equals, and 2 to the 5th is 32. And we get x equals, and 3 to the 5th is 243. So we'll get -243. And that's our solution set for this one. Again, plugging it back in, checking that both of them are valid answers, always a great idea, especially in ones like this where we have rational exponents, or when we're doing radicals. Those are two times that we really want to make sure that we check. But since it's just tedious, it's just plug and chug again. I'm going to leave that to you guys. So this one looks a little bit more complicated. We have the quantity x squared minus 2x squared minus 11 times the quantity x squared minus 2x plus 24 equals 0. But in fact, we already have this squared, and then we have this here. So if we just let u equal, quote unquote, this, we have u equals x squared minus 2x. So we already here have u, and we have it squared already, minus 11u plus 24 is equal to 0. Now we can factor this out, and we have 3 and 8, and they're both negative by our law of signs. And so we get u equals 3 and u equals 8. Alright, now this time we have a little more complicated because our u is x squared minus 2x. So we have x squared minus 2x equals 3, and x squared minus 2x equals 8. Now we can solve both of these like our regular quadratic. So if we, this first one, if we subtract 3 from both sides, we get x squared minus 2x minus 3 is equal to 0. And if we factor that out, we have x, and 1, and 3. We have a negative in the middle, so our negative needs to be bigger. And so we'll get x is equal to -1, and x is equal to 3. So in the same process on this other side here, we have x squared minus 2x, subtracting 8 from both sides, equals 0. 8 is 2 times 4. And we want it to be negative, so our 4, our bigger number, needs to be negative. And solving is all equal to 0. And using the zero product property, we set each equal to 0 and get x is equal to -2 and x is equal to 4. So we come up with a solution set of -2, -1, 3, and 4. And again, remembering to check. Alright, that's it for this video on solving other types of equations when they're in the quadratic form. Thanks so much for watching. I hope it was helpful. Don't forget to check out my last video in this series when we look into how to solve equations that deal with absolute value. Thanks again for watching.